Solve the system of inequalities in two variables. We'll start by solving each of the individual inequalities, and we do that by graphing the inequality, treating that inequality as if it were an equal sign. And hopefully we recognize this as being a circle that's centered at the origin with the radius of 3, which is going to look something like this. This is not quite perfect, but good enough for a concept drawing. Because we have greater than or equals to, we're going to be graphing this circle using a solid line, and we'll use the test point 0, 0 to determine whether the solution region is the one that's inside the circle or outside the circle. So we plug 0, 0 back into this inequality, and we get 0 squared for x, 0 squared for y, greater than or equal to 9. And this is not true because 0 is not greater than or equal to 9. And so the region that solves this first inequality is going to be the one that is outside the circle, the region that does not include our test point. Before we do too much more with this drawing, let's solve the second inequality, treating it as if it were an equal sign in order to determine the graph. So this is a line. We'll solve it for y by subtracting x from both sides. So we see we have a y-intercept at 3 and a slope of -1. So we start at the ordered pair 0, 3 with a -1 slope, but because the inequality is strict, the line needs to be a dotted line. Again, let's choose 0, 0 as our test point to determine whether or not we're going to be graphing the region that's below the line or above the line. So when we plug 0, 0 back into the inequality, we get 0 for x, 0 for y, and this is less than 3, so our test point does work, and the solution region is the region that contains our test point. So now we need to determine where these two regions overlap. The solution to the system is the region in the Cartesian plane that is both below the line and outside the circle. And so that's going to be this region here. Again, we'll make sure that the line is dotted, but the circle is graphed with a solid line.